Hello. Yeah, this is the last example now for this lesson. Okay, we go on for this example, the last one for the circular measures. Okay, the question say the diagram shows a circle of radius 6 centimeters with a chord. Okay, radius 6. Then now you see the question give you the diagram is below here. Okay, the green one here, not the pink one. The pink one I just expand. This one, right? The circle here, the green color here, is the question give you the diagram. 6 centimeters. So 6 cm here, this is the radius. OA equal to OA equal to OC, which is equal to 6 cm. With a chord AC, right? Length equal to 10 cm. Chord, this one AC chord. This one we call chord, right? The longest chord is what? Diameter, but this one not, okay? So this one equal to 10 centimeter. Calculate two significant figures, the area of A, the minor sector AOC, that means the minor, so you see AOC, that means this piece, okay? The minor, the small one, the small area. If bigger, should be below here, okay? So just say AOC, the sector AOC, or you can read AOCB, doesn't mean the whole area. This one is called minor sector AOC. Then B, shaded areas, segment ABC, that means the blue color here, ABC, the blue color, okay? That's the one they want to find, the shaded area, sector ABC. Now we start. Then you see the pink figure diagram here. I just get from this part AOCB or ABCO, this one. I take this piece out and expand to be this pink color here. Okay, so then AOCB, AOCB, this piece we're gonna work on this piece. So we know OA equal to OC is the radius equal to 6 cm. This one 6 cm. Okay. you need, sorry. Then from this piece, we know if you want to find minor AOC, right? AOC, that means this piece, the whole thing. We have to know the formula. The formula arc length, right, is a theta. We have theta equal to, right now we like formula for theta equal to S over R, right? Another one, you want to find the minor sector AOC. That means they want you find kind of area, correct? And then we don't know this arc length, AC or CA arc length here, ABC, we don't know the length. Then we cannot use it. But we know this triangle because you see this is a center, right? And OA equal to OC is a radius. Then we know this triangle AOC, this triangle AOC is isosceles triangle because we have these two arms equal. So we should know this angle AOC, this angle, maybe use another color here. OCA, this angle, okay, equal to angle OAC because isosceles triangle. Okay, then if we analyze first, if we know the whole area, the sector AOC, then we minus the triangle AOC, the triangle, then we get the area, the shaded area right away for ABC, right? So our job have to find the whole area first and then find the triangle area, the whole area sector or AOC first and then minus triangle AOC. Then we get the answer for the shaded area. Okay, you can see down here also if you want. The big one, AOCB minus triangle AOC, then we get the shaded area. So first we're gonna find the minor sector AOC. Even they did not ask us to find question A, we have to do this way if we want to find shaded sector ABC. Okay, so then we start from this triangle AOC. We see the bigger one, okay? Now we know AC is what, 10, right? In this case, we can draw our line by ourselves. If they can use, you can add the line by yourself. So we draw the perpendicular OB D maybe, okay, name so D here. So we draw the perpendicular OD. Up here. So we're gonna have this one perpendicular, so we know this one should be perpendicular at 90 degrees. So we name this one as a D point. And then we know AC, we know AC equal to 10. Then when you draw perpendicular and we know this is an isosceles triangle, so this one should be equal, correct? DC equal to DA. This one should be equal. And because AC equal 10, so then we know this one is a 5 and this one 5 also. Okay, and this arm equal, this arm equal, because the radians equal to 6. Once we have this triangle, then break it down, become two triangle AOD and COD. Okay, so we have to find what, if you want to find this, we need to know OD, right? If we don't, either way, if you can find OD, correct, by use the Pythagoras theory, or if we don't need this one, we can use the trigonometry ratio, right? So if we work out from this triangle, for example, in the bottom one here, AOD, so we see the triangle from here. We do another, this one, right? See the triangle AOD, triangle AOD, the triangle AOD. So if I want to use the trigonometry ratio by use the cosine, can I? Because we know this side, correct? We know AD, we know AO. So I can use trigonometry ratio, either sine, cosine, tan. But if I use this one, if I want to use two sides here, because I know equal to 5 centimeter here and 6 centimeter here, right? I mean, this one cm, not m, 5 cm. So I can use this one, it's a cosine, right? Cosine is what? Cosine add over hypotenuse. Okay. So I have, if I find the angle AO or OAD. So I tangle AOD. So I have cosine of angle, DAO, sorry, DAO equal to what? DAO, okay, this angle. So become DAO. So cosine is what? Add over hypotenuse. So I have 5 over 6. I have 5, 6, then you can find the angle DAO here. Maybe we name this one as the beta, angle beta, okay. So beta equal to, we're gonna have r cosine 5 over 6, correct? So equal to what? You use calculator, r cosine 5 over 6 is approximate 33, use calculator, okay, 33.56 degrees. So I have approximate, this one equal to 36.56 degrees. Then because we know this is 90 also, correct? This 90 degrees. So we can find this angle, correct? Because we need the formula of the, we have to get the formula of the area sector or either arc length. We need the angle on here, on the center here. So then we can find this angle, correct? This angle here by using the triangle. So we get this one as a theta, right? So we can say this is theta. So find the angle, this one, AOD, angle AOD, AOD, so equal to 180 minus 90 degree, okay, and minus the beta 33.56 degree. So when we minus left, we have approximate, use calculator. We have approximate, let's see, approximate is what? I'll just say equal to what? 56.44, correct? We have 56.44 degree. Okay, we have this one now, this angle, AOD. But we need the whole angle here, AOC. So then AOC, angle AOC. So we get this one. Maybe I like the green color here, AOC. I like AOC. Maybe we get this one as the theta one. Okay, so we have AOD already is 56.44. But we know this angle must equal to this angle, correct? Okay, so we let this one equal to theta, then you times 2. So this one equal to times 2, 56.44. 56.44 times 2 become calculator. So plus is become 88, right? 88 here. 12, 10, 11 degree. So have 112.88 degree. Okay. So now we get theta already. So this is the whole thing here. The whole thing here, we get this one as a theta. This is the whole angle here, AOC. Okay, so we got theta now, and we have radians. Okay, then we can find use the formula of sector area, the area of sector AOC now. So we can get the area of sector, just say the minor one, right? So become the minor sector AOC will equal to what? We can use the formula. This one formula is what? 1/2 times 1/2 r squared theta, correct, from the formula. So we have 1/2 times r we know is equal to 6, right? So 6/2 times theta. Okay. And then don't forget this theta, we have to convert to radian from this formula. We have to convert theta to radian. So we have 112.88 degree, convert to radian, so to times pi, right? Over 180. Then you cancel, make it simple term, become approximate. 102, so you get, final, you use calculator, we have approximate 35.46 centimeter square. Okay, this is the area. So we got the area of the minor sector AOC. Okay, this is the answer for question A. The answer for question A. Okay, this is the answer. Now we go to question B. Okay, now we do B. Find the shaded segment ABC. Okay, when we have this area, sector area of AOC, that means the whole piece here. If we lead every point here gonna be AOCB, right? The whole piece here, the whole thing here. So now we have to get the area of triangle AOC. Okay, so we have the area of triangle AOC we have to find. So we can use 1/2 times base. We know base of 10 times height OD. You can use also by use the Pythagoras, or you can use the formula I give you previous one, because we know these two arms. We know OA, OC, and then okay, this one many formula can use. Okay, so you can use the, right now we want to find the area of the, maybe use all in one, area of the triangle AOC. Okay, you can use either formula 1/2 times base times height, right? Height we don't know yet, but base we know is a 10. Or you can use formula of 1/2 times AB, right? The formula you remember, and the sine theta. Or you can use the square root s minus a, s minus b, the formula I give you before, and times s minus a, c, if you know 3 sizes. Okay, but how you get s equal to 3 sizes, sum it up, divided by 2. Either one you can use to get the area of triangle AOC. Okay, so in this case, the first one base, I don't base I know, height I don't know, so but I can get, but I don't want to use this one. Why? Because if you come back to this one, the second one here, we know theta, we know AB. AB mean OA and OC, so we know already, so we can use this formula. Or either this one, because we know 3 sides, we know AC equal to 10, we know OA equal to 6 and OC equal to 6, so we can use this formula also. So this one we can use right away, either one. But for the first one, you have to find the height, but we know the base equal to 10 already, mean AC here. So you can use either one here, this one. Okay, so I think the most convenient to use, I use this one, the second one, I think. Okay, so we use the second one here, this one, 1/2 times AB times sine theta. So I use that one, okay, I use this formula. So become, sorry, 1/2 A, you can treat this one as a A, and this one as a B. Okay, this one number 6, okay. This one is a 6, number 6. Okay, so 1/2 times AB, A is a 6, B is a 6, times sine theta. Theta we know already from this one, right? But don't forget, yeah, we know this one theta because this formula theta have to use degree, don't forget, okay? We have to use degree. So we can use this one right away. So times sine 112.88 degree. Okay, so you use the calculator. So approximate 1/2 times 6 times 6 times 6 times sine 112.88. Approximate is 16.58, right? The area centimeter. Okay, once we have this one, then we can get the area. Maybe I can use this one pink better because blue gonna represent. So I change this one become blue, okay? We can get 1/2 here. Times 60 times 6 and times sine 112.88. then you get the answer 16 approximate 5.8 centimeter. So then you get now, get this one 56 here, get 35.46 minus 1658, then you get the shade the area blue. So the question B, the shaded segment ABC equal to 35 point, this one, right? 35.46 minus 16.58, then equal to what? 18 something. 18.80 log of about 88 centimeters square. So we have this a final answer for question B, the shaded segment ABC. Okay. So this is a question B. Yeah. Okay. So I think we finished this question. But you can use this one also if you want, right? They should have the same answer. But if you use the first one, you have to find the height. Okay. But so we use the second one and third one later because we have all information, either one. Okay. So now we finish this lesson, circular measures, and then I will post it out for your, I will give you handout. I mean the question for your practice, okay? They have total about 15 questions. It's nice to practice. I think this one can be part of your SAT. And the question they practice, they have from the easy one to the harder one. And the harder one can break it down to be like small question, like in SAT pattern. Okay, but you just practice, it's up to you, but I won't collect your work, okay? And I will give you answer key for each question. The whole thing is 15 questions. Okay, so I think we finished this lesson. Okay, so I think that's all for today. Okay, bye-bye. See you next class. Bye.